Uh, Very good day, students. So we'll continue our discussion on the lecture series on generative AI and agentic AI for mechanical engineers. So today what we'll see is we see about the opportunities and challenges available in generative AI, particularly with respect to mechanical engineering. Before getting into opportunities and challenges, we'll just see a quick overview of different generative AI models. So we'll be beginning our lecture with image-based models. So the first model is a generative adversarial network, in short called as GANs. So you would have heard this GANs in super resolution projects. So if you have enhanced any image through internet, then you would have heard these terms. So generative adversarial network is nothing but it is a game theory based training method where you will be having two sets of CNNs. So one will act as a generator, whereas another will act as a discriminator. So as the name indicates, the generator will generate the image, which is a synthetic image. As if you see the here, there is a random noise which is fed to the generator, and it will create some image. So this image will be compared with the original image by the discriminator. So think it is like a faculty and a student. So student will write an answer, faculty will evaluate. So based on the feedback, the student will correct himself. So the same process happens in GAN 2. So hence the name adversarial training. So in engineering use cases, they may be used for synthetic data generation, synthetic defect image generation. Uh, so where these generated defect images can be used is they can be used for training the model. So if you see the defect images are not very much available for common user because those will be available with big companies which are doing analysis in large scale. So what you can do is you can use GANs for generating synthetic defect images which can be used to train the model for detecting images. So it's a to and fro process. So next is the advancement to the generative adversarial networks, which is called as a diffusion model. So current image generation models are using this diffusion model or a variation of this diffusion model. So what happens here is that it starts with a noise. So what we'll do is we'll feed the model both things, a real image as well as a noise. So what the model will do is it will learn to turn the noise into real image. So using the actual data, which will be available in the form of feature vectors, so the model will try to alter the noise. So this, one minute, I will take the point. So this will be your random noise. This will be the original image. So what the model will do is it will try to recreate the original image from the random noise through learning. So that is what happens in the training, and during testing, if you give a prompt, then the image will start being generated. So what I wanted to highlight here is that it doesn't happen in a single step. As you see, it happens in a step-by-step manner. So step by step, the random noise will be converted into a meaningful image through the alteration of the image tensor. So that's what happens here. So this can be used for, as you can see, many synthetic image generation, design generation. So the applications are numerous for this stable diffusion model. So then there are the large language models, which we all know, LLMs, ChatGPT, Gemini, Claude. So many large language models are available now. So what they do is they are trained on large corpus of text data. So that's why they are called as large language models. So because of their huge training process, they are able to do multiple NLP tasks, natural language processing tasks. As you can see, they can do named entity recognition, text data collection, fine tuning, text summarization, text completion. So multiple tasks are possible by a single model. So before LLMs, what you have to do is you have to use specific model for specific purpose. So for named entity recognition, you may use a different model. For text collection or text compilation, you may have to use a different model because one may not do the work of another. But with the LLM, everything is possible. So these are some of the statistics. 175 billion parameters is small compared to the frontier models which we now use because they are very, very high-end models with large parameters more than this 175 billion. So let's stop here and discuss the applications further in the next video. Thank you.